Hi everyone. Wanted to show some of the instruments that I collected. Second, let me see if it is live. Live, yes it is. Right, so I got my hands on this cute little thing. Not going and explaining all of this, but there's some kind of marks. I'll try to put them. So I will try to put the name of this in Amazon, and it's widely available. It's somewhat kind of accurate. So when I try to check the accuracy on my own, I have no other means to check. So this is all what I could do. So there is a degree here, 56 degrees and 5 minutes. This is the opposite side. I checked for instance, if I would check the, let's say this side, it's 85.9. So this is, so we check like somewhat. I think it's not 65 now. It looks like it is 60. Yeah, it is. It is. So we can see. I'll show it on the camera if you can read it yourself. Not focusing. Sorry. It's a 75 mm lens. Okay, there it is. Anyhow, you get the idea. Sorry, this is going to be a bit slow, so please grab some drinks if you would like. And so the Vernier, I don't have to explain to anyone. You can get unlimited videos. So what we actually did, I cut a piece of paper into 8 pieces. One, two, three, four, five, six, seven, 8. And oh, besides, I'll tell you the name in the description after the video ends. It came in a box like this. This very, very less expensive thing. And but it turns out to be highly accurate. So let me come to demonstration. So this is how you adjust the dial behind here. There's a dial here. You can make in different combinations. Say, for instance, you can remove this one, and then you can remove to this side, and then you can measure these degrees, wider degrees. So if it is here, then you will be limited to 50 degrees, all the way up to 50. Here is 50. So it's going to go all the way till here, and that's it. This is all you can get. Now let me explain something very, very important here. So for instance, if I want to measure this angle, so I'm gonna keep it here, snug. For the demonstration purpose, I'm not going very accurate. So let me, okay, this is, I think I need to go a bit more wider. This is already above 50. I can't measure on this. It has to be a small 36, let's say, okay. So this one is 36 degrees and 2 minutes. Maybe let me pick another one. Okay, 33 degrees and 10 minutes. So I keep it here, and then I dial it down to 33, 33, 33 degrees and 10 minutes. That is what my earlier measurement says. Okay, somewhat. Now, yeah. So here we have 1, 2, and 3. And then you can see these 60 minutes. So 1 degree is divided further into 60 minutes. And each, this is the Vernier scale. My apologies in case if I mix the terms because I'm not an engineer. So this one is the Vernier scale. It's called Vernier Bevel Protractor or something. So this is like 10 minutes, 20 minutes, 30 minutes, 40 minutes, 50 minutes, and 60 minutes comprise just 1 degree of this. So 30 all the way to 30, 40, you have 10 degrees. And the middle line is the 5 degrees. So 30 to 35 and 40 and 45 and 50. Let me say that again. So let's say this 0 is at 30 degree right now. Oops, I think it's not shown clearly. Some focusing problem. Yeah, there is not enough of light. Okay, so now I'm gonna change this slightly, let's say half a degree. You can see that, half a degree. Now you have to see which line aligns the best. So I can see it here that 30, there will be only one of these lines will be aligned below. You will now find all the lines being aligned here. It is designed in a way that only one line will be aligned. All other lines will be shifted either to left or right. only one line. So in this case, it is now I adjusted 30 for easy explanation. And as you can see that 0 mark is in the middle of that degree. So if I would re-measure this, so we can say 33. Recalculate, I would say. So it's like a 33 and 10 minutes. So 10 minutes, how do I get it? 10 minutes meaning this is the 10 mark. And in between the 10, you can count. I could be wrong. Correct me if I'm wrong, but this is my understanding about it. There are 2, 4, 6, 8. 1, 2, 3, 4, 5. The 5 divisions beneath, and so the each one is like a 2 degree. Sorry, 2 minutes. So 2, 4, 6, 8, 10 minutes, and 12, 14, 16, 18, 20 minutes, 22, 24, 26, and 28, and 30, and so on, and 60, and then it will comprise 1 degree. Just for you to know, 1 degree of on the Earth, its Earth latitude is 60 nautical miles, which is basically 183 kilometers. 1.853 is the conversion. So you multiply that nautical mile with the 1.853 and you get 1 nautical mile. Okay, so let's come to the calibration process. Sorry, my mobile. Okay. Okay. So what do I do to? Okay, I go to this. So you can see I need to wait for a while because my screen is lagging. The computer is ramping up. So I calculated all the degrees using perplexity, and it converted all these degrees. I marked it here carefully after measuring with this. And then they changed that into decimals. That is a different topic altogether, how to change it into decimal. Anyhow, when we calculate all of that, we're supposed to get 360 degree, and we're getting 359.9, which is basically 0.1 degree. 0.1, it's saying that about 6 arc minutes. So you get the idea. It's pretty accurate. So 8 pieces are short by about 6 arc minutes in total, very, very small. This is the error, actually. So the error is instead of 360 minus 359.9, just 0.1 degree, which itself is a lot, actually. It's not supposed to happen anyway. But when you when you divide a 360 into 8 pieces and you measure it, you tend to make error. That's the error. So how do I check? Let's say if I want to check this 36 degree, and I use the vernier calipers, and I use the vernier calipers to measure this hypotnuse and the opposite side. So this is the right triangle, this is the opposite side of that angle, this is the adjacent side, and this is the hypotnuse side. It's a trigonometry basic that you learn in your basic school, 10th grade maybe, or a couple of years later. So the angle is here, the opposite side is here, the adjacent side is here, and the hypotenuse is here. You know the formulas. The sine theta equals opposite side by hypotenuse, and cos equals adjacent side by hypotenuse, and tan equals opposite side by adjacent side. All of that formulas. Let's not go into that. Let's come to a practical explanation. Okay, if I want to check this 36 degrees in 2 minutes, whether if it is correct, how can I check it? So first I do a shift sign, because we're dealing with opposite side. That's the reason we're using sign. If you have the adjacent side, because for instance, let's say you have a piece you're cutting in a 45 degree. This is the practical application. You have a piece of wood or plastic, whatever. You cut that into 45 degree and you get a 45 degree angle here. So you know you would naturally know the measure here instead of this. That's the reason I took the width of the profile itself. So anyhow, you input 72.7 divided by 126.2. You can get all this